So now after we have imported our main libraries that we're gonna use and we have loaded our data set, next is we have to perform EDA or data exploration. There are some several questions that we have to ask ourselves, and the goal here is to find more about the data and become a subject matter expert in the data set that you're working at. So data exploration or exploratory data analysis or EDA is a critical step in data analysis process. Let me make this one as third point since it's the third step that we are going to work with. So as we mentioned, it's critical step in data analysis process. The goal of EDA is to understand your data set and uncover the patterns, identify data quality issues such as missing values, outliers, and generate hypotheses for further analysis. Let's explore some of the key questions that is involved when doing an EDA. The first question here is, what question are you trying to solve? Why is this question is important? Before diving into any analysis, it's essential to clearly define the problem that you're trying to solve, as we have did on the first session. To help us, define the problem in a very efficient way, first we have to focus on analysis and the data relevance to these analysis that you're doing. Also, we have to choose the correct techniques for processing and modeling and ensure that our findings will lead into an actionable insight. Some questions are involved here. What does the data look like? And what is the distribution of the key features as we have done when we saw the recommended plots? Also, some correlational questions as when we have plotted the correlation matrix. Are they in relationship between the features? How do each certain feature relate to the target variable, which we are trying to predict whether a patient might have a heart disease or not? Also, there are some several predictive questions like, can we predict a certain outcome? Can we predict a customer or a patient based on his data that we have? In our example, if you're working with a heart disease dataset, the question should be, what are the key risk factor for a heart disease? So when we look into the correlation matrix, you will find some key variables or key features that have a high correlation with the target variable or the dependent variable when which is in our case whether a patient will have a heart disease or not. Also, can we ask in case in is there any relationship, for example, between the age and cholesterol level? And what are the features that strongly predict whether someone has heart disease? So these questions we have to do some analysis to answer these questions. The next question here we have is, what kind of data do we have and how do we treat different types? Why is it important? So understanding the type of data in your dataset is crucial because different types of data require different techniques for analysis or cleaning and modeling. Some common uh, uh, data types that we'll work with is like numerical or quantitative data. These are continuous values. Example include like age or cholesterol level or salary. So for example, how do we treat these type of data? Numerical data is often analyzed using summary statistics like mean, median, standard deviation. When we have, if you recall that we have called df dot describe function, and it has analyzed the mean and the standard deviation, the minimum and maximum values, and that will help us to visualize with the histograms or box plots or scatter plots to understand the data itself. The next type of data, and please pay attention to these type, into this type of data, which is categorical data. These represent like categories or groups. Example include like gender or occupation. So these categorical variables, we cannot do an analysis or just describe them as the numerical values. It has to be transformed into a numerical shape so we can conduct our analysis on. How can we treat our categorical data? We can use like frequency tables or bar chart or pie charts. If necessary, we can encode these category variables into numerical values as we mentioned for machine learning tasks. An example here, if you are working with a data set on heart disease, like the age and the cholesterol columns, these are numerical, while gender and smoker, the status of the patient, is he a smoker or not, it comes as yes or no. And these are not numerical values. So we have to encode or transform these uh, data type into a numerical values for to build our machine learning model. Next, we have the question is what missing from the data and how do we deal with it? It's important to handle our missing data, which can introduce bias or reduce the reliability of your analysis. Handling missing data appropriately is crucial for like accurate results. So, how do we approach such issue? How do we handle the missing values? We can use some functions like, for example, df.drop or fill the missing data with mean or median. Median is more robust to outliners. We can just fill the missing values, and we will see in case if we have any missing values in our data set how we can fill these data with, for example, the median or the mean. Also, there's an interesting functionality which is called forward or backward fill for time series data. Missing values can be filled using previous or next available value, for example. Let's take in our example, in case if we have any missing values in our heart disease data. Let's take an example if the cholesterol column has some missing values. Like we might fill them with the column mean or median. The fourth question here we have to answer when doing an EDA is where are the outliners and why should we care about them? Outliners are data points that deviate significantly from other observation in the dataset. The example of outliners like sort statistical analysis leading misleading conclusion or indicate data errors, which happens normally when data entry it's been entered like incorrectly. So how do you detect outliners? When doing a statistical using statistical methods, outliner can be detected using methods like z-score, which identify points that are certain number and of the standard deviation away from the mean, or the IQR, which points that lies outside 1.5 times from the IQR above the 75 percentile or below the 25 percentile. So how do we handle the outliners? We can remove or correct them. If if the outliners are data errors, they can be removed or corrected. Transformation. There are some mathematical transformation like log square or square root to reduce the impact on the outliner. The last question here we have to ask when doing an EDA, how you can add or change or remove features to get more out of your data. There's something called feature engineering here that we might use to come up with new features that could lead us to have a better accuracy of when doing the machine learning building. Feature engineering is the process of modifying or removing feature variables. Variables here are when we have described our data and we could see that we have the age and sex and CP, the cholesterol, some of these variables which we are going to explain in detail, and how it relate to the target. So these are the variables we call them, or the features that help predicting the target variable, which one in our case is yes and zero, on the other hand is no. Feature engineering is very important, that is to improve the performance of the model or to make the data more understandable. Some techniques are used in feature engineering, like creating new features when combining existing features or variables to create new ones. Will and that will give us more information. Example: if you have the height and weight in your dataset, you can create a new feature and can call it, for example, PMI. Using the formula, you can come up with a certain measure that could help you trigger whether is there is any relationship between the height and weight when predicting a heart disease. Also, you can apply transformation to make the data more suitable for modeling. When it comes to encode categorical variables, as we have discussed before, that some of the variables that we have sometimes it's not a numerical values, it's yes or no, it's a type, so we have to encode these or convert them into numerical representations for machine learning. In case if we have done some correlation analysis and we find some of the variables or some of the features are not very important, so we also can remove them or remove the irrelevant features which also are redundant or too correlated with others. For example, in our dataset, we can create a new feature, call it as an age category, to categorize the patient into groups like young or middle aged or seniors. This could help in the analysis of how age impact the likelihood of heart disease. So this is the main points that we are gonna go through when doing an EDA. So stay tuned for the next step when we handle each of these questions with coding.